electricity, right? So 1, 2, 3, 4, 5, 6. Yeah, it's just 6 of you. So we'll try our best to make this work, right? Um, Today's class will just be about a little bit about a brief review about subsets and supersets since some of you did not grasp that well. And after that, we will do representation of sets, right? Please remember to turn on your cameras, mute your mics, ask questions, and because it's a few of you, then we will see how it works with the questions and answering of questions, okay? But so first we will do finding subsets. Okay, we have write are the subsets of set E. This is activity 1, number 6. Write are the subsets of E. As I mentioned yesterday, a subset is, we can see a subset is a part of another set, right? Every element must be in that set in order to be a subset. So a subset doesn't have to be exactly the same subset can be a part of, but its element must be found on the other set, right? So because we are doing subsets, we are to write all the subsets of set A. Anyone has an idea how to write a subset? How will we find the subset of set A? Anyone knows what could be a subset, a possible subset? You do not, as I mentioned, you do not have to be right. We can always try our best, right? So, anyone has an idea what a subset? Maybe just share one subset that you think this set could have.
Null, miss?
Very good. It could have a null set. It's okay, Kami, don't worry. Um, very good. A null set. Anyone has any idea? We're just trying to figure it out together, right? So, because I have it here, because the set, as we can see the set here, we have A, comma, and we have A and B, right? The null set is a subset of every set. You could have any set, and the null set will always be a subset of that set, right? We can also have A alone. Why? If we have this A, then that means that it is part of the big set, which is A, right? So we can also have A and B. Why we could have A and B? Because that is found on the bigger set, right? And then we have the set itself. A null set and the set is itself are always subsets of the set, right? So if I have only a set with A, then that means that the subset, we know that a subset will be the null set and just A, right? Because as I mentioned, the null set and the set itself are always subsets, right? Now, the whole amount of subsets which I have in a square bracket, that is called the power set, right? So because A, let's say we have here the subsets and we have the null set. Because the null set is a subset of A, we say that A is the superset, right? The A with the set A there is the superset. The subsets are listed below, and all the subsets together are the power sets, right? You do we get this now? Do we or do you want me to repeat?
Miss, you could do an example, Miss.
We could do an example. This one is an example of the one that I have here, right? All subsets. But now I think I have it. Let's do the one that has write down the power set of the following sets. Because we know A and B, A is a subset of A and B, what could we say are the subsets? Let's find the subsets. Remember the ones that I have here? It's basically the same idea. What could be a subset of A? Just what do you think? What could be a set that has, that won't be a set. What could be something that will be found in A? Remember, a subset, all the elements of a subset are found in the big set, which is set A. So, because we have A equals to A and B, a subset automatically, the one that we know could be
Null.
null set, right? Right? Now, we could have A, but why could we have A? Because that's a part of the big set, right? Right? That's a part of the big set. Now we could also have B by itself because it's also an element of that set separately, right? But we could also have all the set together, right? We could have all of it together. Why? Because as I mentioned, the null set and the set itself are always subsets of the set. So these are the subsets. Now, all these together, if I ask you for just one subset, you could give me the null set, A by itself, B by itself, or the set by itself, right? But now, all of these together are what we call the power set. Together, every subset of the set A is the power set, right?
Yes, Miss, thanks.
Okay. Now, what will we see is the power set of the following set. E is equal to 5. As I mentioned, 5 is used to represent what?
0.
No, it's not to represent 0. It's to represent a null set, right? A null set. So what do you think would be the subset of this one?
Just null, Miss.
Just null. Very good. You could just null. Why? Because it doesn't have any other elements, right? So as I mentioned, by itself, like by itself, a subset by itself is just a subset. But when you have all the subsets together, then that is the power set of the set, right? So what would be the power set of E? What will be the power set of E? You have any idea? Remember, the power set is the all the subsets together. So because E only has one subset, right? Then the power set is just that one. It's just one, right? Because it's that just that null set. We cannot say the power set are two subsets because the set does not have two subsets. It just have one. So because it just have one subset, then the power set will be only that subset, right? Now in A, because we have 1, 2, 3, 4, 4 is the amount of subsets A has, right? So all of those are the power sets. So that is for this activity. I have it here also. If we find the subset of x equals to a, comma, n, we have the subsets here. We could have a by itself, we could have n by itself, we could have the set itself here and the null set, right? So these are the subsets, but all of these together are the power set. Remember, when we ask for a subset, we can say find 2 subsets, find 3 subsets, 4 subsets, but when we ask for the power set, then we need all the subsets, okay? So that is it. Now we have set A here, which is the set of odd numbers less than 10. We are to list the elements and close them in curly brackets. And we list the elements that are found in this set. What is the set of odd numbers? Can someone share an element? Who wants to share an element of
One,
this set?
1, 3, 5, 7, 9.
Okay, very good. We have 1, 3, 5, 7, 9. But what we want now is to enclose that list in curly brackets, right? Just as I had here in a curly bracket. Like in this type, enclose that with your commas and everything. So we will have curly bracket. We will have a curly bracket. We will have set A now equals to curly bracket 1, 3, 5, 7, and 9. So what we did here is we represented this set in another form, right? We not only have words now, but we are having in another form. So that is our topic for today, representation of sets. So firstly, we have different notations to represent a set. They differ in the way in which the elements are listed, just as I mentioned, right? We change the elements here were just in a word form. But what we put in another form, we list it in our curly brackets. So the 3 set notations used for representing sets are the semantic form, the roster form, and the set builder form, right? We will go over all of these. The first one is the semantic form. The semantic notation describes a statement to show what are the elements of a set. This is like just the one I gave you, right? We have, for example, set A is the list of the first 5 odd numbers. Because it is a description, then it is called the semantic notation, right? We also have set B is the set of students at CPHS, right? Why? Because we are describing a set. Then we have set C is the set of persons with COVID-19 in Belize. Those are the semantic notation. Why? Because we are just describing the set. Now, what would be our next example of this one? What would be our next example of the semantic form? Ryan, you could just access, remember this will be in Google Classroom. So I have another example of this one,
Miss?
right? Yes?
Miss, I have an example, Miss.
Okay, you can share your example.
Set D is the amount of sheep in that herd.
Okay, very good, right? Why? Why is that semantic form? Because it is just a set that is describing the set. Now we have the roster form. This is the most common form used to represent sets, right? Why? Because its notation It's the notation in which the elements of the set are closed in curly brackets separated by commas. Oh, this is just what we did in our little activity, right? We represented one set with curly brackets and commas. So we have, for example, B is equal to 2, 4, 6, 8, 10. We have those separated by commas in a curly bracket, which is the collection of the first 5 even integers, right? So if what would be the, um, the semantic form here? If we put set B is the collection of the first 5 even numbers, right? And set B here with the list is the raster form. Why? Because we have it enclosed in curly brackets and it's separated by commas. So in raster form, the order of elements of the set does not matter. For example, the set of the first 5 even numbers can also be defined as 2, 6, 8, 10, and 4, right? The order doesn't matter as long as you have the elements in that notation. Also, if there is an endless list of elements in a set, then they are defined using a series of dots at the end of the last element. This is talking about row what? Infinite sets, right? The one that continue. So if I was to say the set of whole numbers, but how will I write the set of whole numbers if it's a lot? It's infinity, right? So we just write our 0, comma 1, 2, comma 3, and we list the 3 dots and we close our curly brackets, and that is how we write. Now, for example, infinite sets are represented just as what I was mentioning. X is the set of natural numbers. Because we cannot represent all the natural numbers in a set, right? That's, as I mentioned, those are infinitive. It keeps going. We just write maybe up to 5, and then we continue with the 3 dots there. So in final raster notation of sets, as I mentioned, it doesn't end with the 3 dots. Why? Because it's finite. We can count them, right? So we have the first 5 natural numbers, 1, 2, 3, 4, and 5. Those are in raster notation. Why? Because they have curly brackets and they are separated by commas, right? Now the infinite raster notation has the same properties. It's included in a curly bracket. It is separated, by commas, but it ends with the 3 dots. There should be 3 dots. Because the set continues, we cannot see its end, right? Now we have the set builder notation. The set builder notation has a certain rule or a statement that specifically describes the common feature of all the elements of a set. The set builder form uses a vertical bar in its representation with a text describing the character of the elements of the set, which we have, for example. And I know you have seen these examples because in every PowerPoint we have, in every one that we cover, we have the 3 different types of set notation. Those that we have, we didn't mention it because you could have identified that we also put this kind of notations, right? So we have E equals to K, and see, it is using a vertical bar, right? And we see K is an even number where K is less than or equal to 20. So the statement says all the elements of set A are even numbers that are less than or equal to 20. So sometimes what's that? A colon is used in the place of the vertical bar. But most of the time, this is how a set builder notation will look like, right? The key with a little bar, description, and maybe something that is there to tell you how long is the set, or what are the conditions of that set, right? So we have another example. X b equals to x, where x is an odd number between what? 11 and 20, right? Just that I had it that it could also just tell you this one with the 11 and the 20. Sometimes this whole statement is excluded and then we just have numbers. Why? Because it means the same thing. We know that 11 is less than x and x is less than 20. So that means that the number should be in between of those ones, right? So because sometimes the set builder notation refuses to use a description that it would always include like a condition, which is this one. But this can also be represented in this form, right? So if you have this one, x is an odd number between 11 and 20, should be here, and 20, then you know what this is asking for. However, don't panic when you do not see this phrase and you only see this x notation here, where we have 11 is less than x, but x is less than 20. Or we can also read it like x is more than 11, but it is less than 20, right? So, as I mentioned, let's see set C. Set C does not have the same description, right? Set C has, oh my gosh, what is that? We have only, let's see, only symbols that I can't understand. Don't panic. I remember this little E form represents elements. So what this one is saying in C is that x is an element of the natural numbers where x is less than 4. So we know that the only natural numbers, positive natural numbers that are less than 4 are 1, 2, and 3, right? If we were to represent that in another form. If we were to represent this in raster form, we will have another thing. But this is set builder notation. As I mentioned, we will not go in details with this one today because that will be our topic for next week. But this is how it is represented most of the time. So, the first notation that we covered was the semantic notation, right? Semantic notation, where it was a description. It was just a description of the set. Now, the raster notation was the one enclosed in curly brackets and separated by commas. And the set builder notation is the one separated by a vertical bar and it has like a little condition, right? But if it does not have the description, it will have the condition. So this is basically the 3 types of representing a set. Do you have any questions? Any questions? Anyone wants me to repeat anything that I mentioned? Yours is no.
Miss, I didn't quite get the set builder form.
Okay, the set builder form. I will go over the set builder form. Remember, as I mentioned, we will not go in depth with this today. The main idea here is just to get how it looks, right? How the set notation looks. So, the set notation always has a little bar, the vertical bar as I have here. It will, if it doesn't have that bar, it will have a colon. If it doesn't have this bar, then it will have a colon. But if it does not have any of those, then we cannot say it's a set builder notation. Why? Because it does not have the characteristic of a set builder notation. If we only had X is an odd number between 11 and 20. That is a semantic form, right? But the set builder notation always has that little vertical bar. So in order for you to identify that, you should always have that in your mind. It will have a vertical bar or it will have a colon, just to identify it. It will have like a little description. The description can be in text form or it can be just in, um, just a moment. The description can always be in text form, just like the one we have here. X is an odd number between 11 and 20, or it could have like a little condition there where X is more than 11 but less than 20, right? So this is basically the set notation. It has a little vertical bar, right? And it has a description. The description can be in text or just in symbols, but it has a description and it has a vertical bar. So those are the characteristics of the set builder notation, right? Do not confuse, well, it can be confused with the roster form because the roster form are just listed in the curly brackets, right? Remember? But this by itself is what we call the set builder notation. We are not talking about the listing of the elements. No, we are talking about how the set is represented. It is not giving you a description like or a statement like the semantic form. It is not giving you numbers separated by commas, but it is giving you a description, and it has a little vertical bar there. Do you get it now, Gerald, or who was it that asked?
Yes, Miss.
Okay,
Miss, I have one question, Miss, for the
yes.
homework. It says student section 2 for week for the second activity.
Okay.
It says students will list the elements of the following sets in set builder form.
Okay. I think I have some of these on our activity. Right now we will go to that, okay? So so now that we have covered all of these ones, I want to cover a little bit about Venn diagram. Right? A Venn diagram is also a representation of set, but it is a pictorial representation of set, with each set represented as a circle. The elements of a set are represented inside the circle. Sometimes a rectangle encloses the circles, which represents the universal set. And then we have here how it is given, right? The Venn diagram represents how the given sets are related to each other. We will not go in depth with it. This is for you to know how a Venn diagram looks and what is it for, right? So it just represents the given sets, how the given sets are related, and it is a pictorial representation of sets. So that's the only thing you need to know about Venn diagrams right now. So you cannot get confused with Venn diagrams, right? Because you know those are circles, it's enclosed with a big square, which is the universal set. And this is way different from what we just covered with the other notations. So now we have choose the correct set notation. X is the set of all positive integers which are multiples of 7. Is this in semantic form, roster, or set builder?
Semantic.
Semantic, very good. This is semantic notation. We have Krista, Ozair, Ryan, the two Ryans, Yuri. Please answer some questions. Gerald is the only one answering in today's class. Right? If you are having trouble with your internet, I understand too. So we have set A equals to 1. We have half, 1/3, 1/4, and we have dots there, recurring dots. Is this semantic, raster, or set builder notation? You could also type in the chat box, guys. If you don't want to speak as Gerald is, then you can type in the chat box, what do you think? Is this semantic, roster, or set builder notation? Anyone? Do you have? I have to call on Ryan. Ryan says his internet is unstable. Ryan says set builder. Remember, set builder always has a, oh, maybe you got confused with the half, the 1/3, but those are fractions, right? But the set builder will have a vertical bar, not a cross bar, the one that looks, let's see, like this. This is what you're seeing right now. But we don't want that one. We want the vertical bar for set builder notation, but good try. This is raster form. Why? Because it's enclosed in curly brackets, it's separated by commas, and it's an infinite raster form, right? Because it continues, the set continues. So we go to the next slide where we have, now this is activity 2 number 1 from your assignment 2. So please take note of this one. We have represent the following sets in raster form. The set of all natural numbers greater than 8. The set of all natural numbers greater than 8. This is semantic form, right? This is a semantic form of representing a set, but we want it in raster form, which means we want curly brackets and we want separated by commas. So, what will be the set of all natural numbers greater than 8?
Miss, it will be infinite.
Yeah, correct. But how will we start representing it? We'll start from 9,
Null.
right? No, that's not null. Remember, we are trying to represent in raster form, to have it a list, like a little list. So what we'll have is, just a moment, we'll have, let's name it set A equals, we will start from 9 because it's saying natural numbers greater than 8. So it is 9, then what?
10.
10, very good. Then we have 11, 12, 12. And we put our dots. Why? Because it doesn't have an end. Now we have the set of natural numbers between 2 and 10. Set of natural numbers between 2 and 10. We are not to include 2 and 10 because it's saying between, right? So the natural numbers between 2 and 10 are
3, 4, 5, 6,
3,
7,
says
8,
Yuri,
9.
very good. 3, 4, 5, 6, 7, 8, and 9. Remember, it's a raster form, so we have to enclose them in curly brackets and separated by comma. So the last one we have the set of even numbers greater than 5. What will be the first number here?
6.
6, very good. Because it's even, right? Then we have 8, because we're talking about even numbers. We then have 10, 12, and very good, Yuri. And then we finish it with our dots. Why? Because we don't have a limit, right? This is the set of even numbers greater than 5. Because this set doesn't have an end, we include it in our, we put our 3 dots and finish our set there.
Miss,
Yes?
for number 1 and number 3, you have to put it like that, or you could just put the infinite sign.
No, put it like that. Why?
Okay.
Because if you put it like the infinite sign, then you are not making a raster form notation. Why? Because you will not have any elements to separate in commas. So that will not be an example of a raster form. Just keep that in mind, right? So now we have, I think, this one that you were asking. This is activity 2, section 2, right?
Yes, miss.
Represent in set builder notation. This is the one that Gerald was asking. The set of whole numbers less than 20. Aha! How will we write this one? What are the characteristics of a set builder notation? What helps us identify a set builder notation? Yeah, very good. The vertical bar, right? The vertical bar. This is what helps us identify. So we know that we need to have something like that. So we can say, let's name our set D. D, I don't think that D equals, in the bracket, X, right? We put our vertical bar, sorry. We could put X is a whole number less than 20, or we could put V equals X, where X is an element. Let's see if I can add a little E sign here. Let's see, just a moment. Um, just a moment, guys. I'm trying to find that little element sign. Here. Okay. So X is an element of the whole numbers. Whole numbers is represented by W, right? We could also have it in that way. X is an element of the whole numbers where X is less than 20. So these are both ways to represent what we just said, right? It's saying the same thing. Remember, it has a vertical bar. It could have a text description like we have there. X is a whole number less than 20. Or it could have all symbols where X is an element of the whole numbers and X is less than 20. It's saying the same thing. You just have to know what each symbol means, and if it's easier for you to just do like the example one that I have there, that's okay, because next week we'll cover more about that, right? If you think that how I write it on the second one is challenging for you, then we will look at that on the on next week, right? So you choose which one is an easier method for you for your assignment, right? Now we have X. For the ones that are not answering questions, but you are here and you are sharing in the chat box, are you getting this one? Did you get this example?
Yes, miss.
Okay. We have number 2. X equals to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. How would we write this in set builder notation? Somebody tell. How would we write that? Was it 19? Yuri, we are not talking about listing the elements, right? We are just trying to put it in a different notation. We are trying to represent the set differently, right? So how would we represent this one? We could have if equals to what? Anyone has an idea? Remember, we have it here, the set builder notations. How would we represent this one? What are the things listed there?
Xmas?
No. How can I? It's X, yes, but what could be used to describe this set? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday are what?
The week?
They are days of the week, right? So we can include that in our notation. Very good. Very good, Yuri, and very good, who's it? Yuri, right now we will develop from your example, right? So we know that these are days of the week, so we could put X, right? The vertical bar, don't forget your vertical bar, where X is what? What we put here?
Is this we could put whole number or what?
Remember, we are talking about number 2. We are talking about number 2. About Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Those are not whole numbers.
Is this confusing? Is an element, miss?
Um, okay. Well, Yuri, could you repeat what you said? I couldn't hear you. Okay, good try though. We could put X is an element of the what?
Of the week. Days of the week.
Days of the week. We can put X. If we put it in like in this form, see, element of the days of the week, right? Or we could simply just put X on the vertical bar. X is the days of the week, right? Instead of this element, we can write X is days of the week, and that is everything for number 2. So as I mentioned, right, these are in your activity, right? So what set builder notation does, remember, is just a little bar and the description of what the set is about. So that is basically for the representation of a set. So to end on today's class, I want to tell you what is a Venn diagram. I just covered this briefly, but what is a Venn diagram? What is a Venn diagram? Or share anything that you remember about a Venn diagram.
This Venn diagram is an illustration that uses circles to show the relationship among things or finite groups of things.
Okay, very good. A Venn diagram is a pictorial representation of a set, which is also an illustration, right? It represents the relationship between different sets. So that is a Venn diagram. As I mentioned, we will not go in details in Venn diagram. That is the only thing we need to know. And this was just to make sure you were putting attention. So that is for today and that is for this week. If you have any questions concerning these topics, you can always message me and we will discuss it. And as I mentioned, this is the end of week 7. So that is it for our class. I hope you have a good weekend. Hopefully, next week we have everyone. Because of the current, we couldn't have everyone on today's class, right? But that is it for today. And may you have a good rest of the day.
Bye, Miss.
Goodbye.
Bye, Miss.
Goodbye, Yuri.
Bye, Miss. Bye, Miss Catzim. Bye, Miss Mai.
Goodbye, Ryan.
Miss, do you
Goodbye.
know if the other teachers will have class too?
I'm not sure. I'm not sure. I think that if there are some of you, they will be having class.
I will send a message. Miss.
Okay, yeah.
You would need to
Bye.
ask, guys, because some teachers don't have current today. So you would need to ask and see if they will be having. Okay?
Miss Mai,
Yes?
can you please send me the numbers of all the teachers?
I will resend it because I had sent it in the group chat.
Yes, Miss. But I when you send it a day later, I entered the group chat.
Oh,
I've
okay.
never received that message.
Okay, so I will just send it again, okay?
Again, thanks. Have a wonderful weekend.
Thank
Thank
you.
you.
Bye. Bye, Miss. Bye, Miss Mai.
Bye.
Bye, Miss Nelly. Bye, Miss Mai. Have a blessed week.
Thank
Thank you,
you.
Ryan.